The next problem I'm going to work is problem 9 from chapter 4. Calculate the pH of a 0.3 molar solution of these three species of leucine: leucine hydrochloride, sodium leucinate, and isoelectric leucine. Now I think I'll work this problem in 3 different videos. That way you can watch them one at a time. Okay, so the first one we have is leucine hydrochloride, and so what does that look like? Well, a lot of amino acids are generally sold as HCl salts. So if you look this up, you're going to find that the amine group reacts with HCl, and what this does is it precipitates the amino acid as a salt, and so we have this form here. So if you put that in water in a 0.3 molar solution, you're going to get this reaction where the carboxylic acid group dissociates, okay, and the amine group generally won't dissociate because its pKa is higher. So we're going to form an acidic solution, which is going to keep that amine group protonated, okay, and so it's going to remain as an HCl salt. So the major reaction we have here is just the deprotonation of the carboxylic acid group, okay, which is going to the hydrogen is going to be donated, the proton's going to be donated to water and give us H plus or H3O plus, okay? So we can make an ice table for this reaction. In fact, I might just kind of abbreviate this. Let's call this LEU plus 1. And let's call this one here on the right, this is actually LEU0, okay? So if we make an ice table, we end up with LEU plus 1, and that's going to, we could say reacts with water, which is a liquid, so we don't consider it, and it's going to form LEU0 plus H plus. Okay, so this is a weak acid, so we can just make an ice table to determine the reactivity and get our hydrogen ion concentration from that, and therefore we can calculate the pH. Okay, so initial change and final, or at equilibrium, we have 0.3 molar concentration of the salt that we've put into solution. Okay, and at the beginning we're going to have 0 and 0 of the products. Then we're going to get minus X for the change, and that's going to give us plus X for each of these products, because we are going to gain that for every X moles of the leucine plus 1, we're going to gain X moles of the leucine 0 and the H plus, okay? And so at equilibrium, we're going to have 0.3 molar minus X, and then we're going to have X and X for the other 2 species. So we can just write a Ka expression for this. Ka is equal to LEU plus 1, 0. LEU 0 times H plus over LEU plus 1. Okay, and so the Ka is equal to X squared over 0.3 minus X. Okay, so 0.3 minus X is the starting material that goes on the bottom, and the products go on the top, and so that gives us X squared. Okay. All right, and so we also know that Ka we can get from the pKa. So we don't know the Ka unless you can look that up somewhere. But we could look up the pKa for that carboxylic acid group, and so our Ka is equal to 10 to the negative pKa, which is equal to 10 to the negative 2.4, which is equal to 3.98 times 10 to the negative third. All right, so then we can set up our Ka expression. Remember, Ka is equal to, we already did this, but X squared over 0.3 minus X. Okay, so if we assume, go ahead, assume x is small so that we don't have to work out the quadratic equation. Now you could certainly do that if you want to. It's not that hard, but in the interest of time and because it probably won't make a difference in a non-significant digit, I'm going to go ahead and ignore x, okay? On the bottom, if we assume x is small compared to 0.3, then we can say that that x is equal to the square root. So we're going to multiply Ka times 0.3 and then take the square root. 0.3 times the Ka, which we have here, which is 3.98 times 10 to the negative third. Okay, and that is equal to 0.0346. So what is x? X is our H plus concentration. If you go back up here, x is our H plus concentration. So just like you did in general chemistry, we can say that H plus is equal to x is equal to, let me just rewrite that. So we could say pH is equal to the negative log of H plus is equal to the negative log of 0.0346 is equal to 1.46. Okay, so we've calculated A. That was part A of this problem. So in the next video, we will work part B, or maybe part B and C.